Right, so welcome to An Evening with Nick Dunhill, who's well known for his scratch building skills and modifying or correcting commercial kits on behalf of his customers. If anyone has any specific requests, please let us know via chat so Nick can cover those too. Welcome, Nick. Thank you for joining us. Over to you.
Thanks very much, James and Ian, and welcome everybody. This is, I don't know, this is something like the fifth or sixth presentation that we've done while we've been making this scratch built model that you can see here on my bench. Second, let me move you.
You're quite quiet at the moment, Nick. I don't know whether you've got there.
Can you hear me, everyone?
You are quite quiet.
Am I? All right.
Yes.
Okay. I'll shout up then. Excuse me. So in a minute, how we'll start this presentation is I'll kind of show you around the model. I'll show you what we've done up to now. I've done a little bit since we last met because I thought that if I did the splashes on this logo, it'd be a good introduction into starting some very, very basic cutting techniques. But for those of you that were here for the sort of preamble to this, you be aware that already there's been a bit of a mini discussion about other ways of cutting pieces of nickel silver. So if anybody wants to ask, if I can ask, wants to ask me any specific questions, I'll try and demonstrate anything that you want. But perhaps we should start with the real basics. I think that's perhaps the way to start. So what I've been doing over the last few years, I suppose now months, is building this loco here, which is a Hull and Barnsley converted C-class locomotive, I believe. Yep, it is built in 1885 and then modified in 1899, according to my blurb here. And that's the loco that we've been shooting for over the last sort of few presentations. We started off by making the smoke box and then the boiler, and then it's kind of moved on to a cab and a footplate. And then I think in the last presentation at the virtual show, we made the chassis and fitted all of the axle boxes and made a kind of a rolling chassis, as you can see, rolls quite nicely. What I've done since you last saw this, for those of you that tune in regularly, is I made the splashers. Now, as you can see, the splashers are actually quite complex for this loco. It's kind of like a rear splasher that's the full width of the bottom of the cab. So its width is from the bottom of the firebox to the edge of the cab, and that forms the splasher for the rear wheel. But the front wheel has a splasher that's much narrower, and as you can see, there's a bit of relief at the front of that for the boss that's on the coupling rod there. So this was actually quite a complex thing to make. It was made out of 1, 2, 3, 4 pieces plus lots and lots of beading. I don't know whether the camera shows that up, but you can see that there's beading along the bottom of the splasher, and then it goes over that splasher as well. And then there's a piece on there as well. They're all extras. And also what there is a piece in the back there, so that when you look underneath the boiler, you can't see the spokes of the wheel opposite. That covers it up, and it gives you that impression that it's kind of built more or less to look like the prototype. All of these pieces here from all of the pieces in the splasher, apart from these obviously curved pieces that are made out of chunks of a circle, really are all rectangles. And as you can see, one of the other things I've done is built this kind of, I don't know what you would call it, inside the cab. It's kind of the extension of the splasher. I suppose it doubles up as a toolbox, and I think this one actually doubles up as a sanding box as well. So what you've got is a rectangular structure here in the in one side of the cab. And as you can see, I haven't made the one for this side. So given that pretty much all of this locomotive is constructed from rectangular sections of nickel silver that have been shaped, perhaps the best place to start this demonstration tonight is how I cut out a basic rectangle. Because from the rectangle, all these shapes more or less are formed. So let's start there. Now, feel free at any point in the demonstration to chip in, you know, because I'm really not the arbiter of this. People may have some better techniques that I'd be happy to hear about. But where we'll start is with my basic measuring and cutting techniques. And I'll cut out a rectangle and we'll take things from there and see where we get to this evening. So this one's a little bit less structured than my normal presentations are, but we'll see where we get to anyway. So
Nick, sorry,
yes.
Just before you start,
Yes,
Kelvin has asked, what thickness of nickel silver?
well, I was going to come on to that.
Okay.
I was going to come on to that. I mean, this is me sort of go-to tool. It's just a bog standard piercing saw that you can get anywhere, really. And I always use 6/0 blades because you want something where the teeth are quite close together, so that you can cut quite thin material. Obviously, the thickness, the distance between the peaks of the blade needs to be about the same order or less than that of the thickness of the material. Otherwise, you'll really struggle to cut any material without distorting it. So I always use 6/0 blades because they'll cut pretty much anything. So there we go.
And as a matter of interest, with the blade, which direction do you cut in?
Well, I kind of opinions divided about this. I think most in lots of applications, you put the blade inside the frame so that you're sawing when you're pushing the blade away from you. Although I know a lot of jewelers, when they're using these thin piercing saws, do it the other way around, so that they're cutting when they're pulling down. You know, because typically what you'll get, just a sec, let me get this into shot. Typically what a jeweler will have, and I've got one as well that fits on my bench, is like a fork-shaped thing like that. And you rest your metal on the top of it, and then you kind of cut into the middle of the fork, and it allows you to, you know, shape things. But I haven't got mine fastened to my bench tonight. So I think the answer to that is whichever you prefer, really, whichever suits you the best. I find I break less blades if I have it so that I'm cutting when I'm pushing the saw away.
Okay.
Anyway, so measuring and cutting. We're going to make this structure inside the cab there, just here. And you can see that's this structure here on the drawing. So we're going to make 3 pieces. We're going to cut out 3 pieces. I mean, I set these pieces aside, actually. Now, these are things that I cut off. This is a chassis for a loco that I built that I didn't use the chassis for. And I've kept this because you can see it's got etched fold lines pre-etched in it. Now, it would be possible to make a box shape by kind of scribing out the shape that you want to make around these pre-etched fold lines, and then you could just kind of fold it up afterwards. But unfortunately, for the purposes of this demonstration, or maybe fortunately, I can't fit the piece that I need on either of these sort of, I always say things like this. They're like kind of bits of kit that have got half-etched lines in them, because sometimes it's convenient to cut something out with a pre-etched fold line on it, so you can just, you know, kind of fold it up. I've got a great big box over there full of all kinds of useless pieces of material, most of which I'll never get around to using, but you never know, do you? So the dimensions of this box, the dimension of the side here is there on this drawing, and that scales out at 33.2 times 16. And I've also cut the top piece already, which is this piece here, which is that. And you can see it's got some holes that I've drilled in it. I don't know whether you can see that on.
Yeah, we can see the
Three
holes.
holes that I've already drilled in it for the sandbox filler, and these two little handles that will ultimately hold levers that work the sanding gear. So I've drilled those already, and I've drilled this. I've already made this piece, which is the rear, but I haven't made the side yet. So let's do that. Right, that was a long way around getting to the first question. Now, I only ever build locos out of 0.45 or this, which I think is 0.3 millimeter thick. It is 0.3. Somebody hopefully will tell me what that is in thou, because I don't really work in thousandths of an inch, much to my dad's amusement, because I'm not one of those people that can work out whether 17/32 is bigger than 46/73. You know, I just I can't do those calculations very quickly, which a lot of people can. Including my dad. But anyway, this material's 0.3. I always use 0.3 for little bits of detail like this, and I always use 0.3 when I'm making a boiler or a smoke box or a firebox, because I mean, it's one of the things I don't understand really. Most commercial kits come with a pre-roll boiler, don't they? And typically the boiler's in 0.45, because pretty much everything that you get in a commercial kit is etched on 0.45. And my slip rollers just won't roll it very nicely. You know, that maybe they're right at the limit of what my slip rollers can handle. And 0.3 is, to me, it seems much easier to form things out of. And also things like this cab, the way this cab's curved here, and the way that the smoke box is curved here, because you've got using a piece of material, a rectangle again, that's only quite narrow but quite long, you can actually bend it round pieces of bar like this. I've got a few of these, you know, sort of down there at the end of my bench that I typically use for forming bits of sheet. And they're just bars, you know, that have got a various diameter. And also things that are very useful is, you know, just drills. Drill shanks are very good for bending things round. And if you get one of those hobbyist boxes of drills, then, you know, you've got lots of different sizes, haven't you, to choose from to get the radius that you need. But if you're trying to form a radius, really, you need to use a drill or a rod that's slightly under the sort of radius of curve that you want to achieve. But you can only really work that out by trial and error, because that depends on things like whether you use brass or nickel silver, or, you know, whether it's half hard or not, and so on and so on and so on. But anyway, let's concentrate on cutting out a simple rectangle, and feel free to ask me any questions while I'm doing that, because I'm sure it's not the most exciting thing, televised cutting. I've got what I'm going to do, what I always do, is just, you know, kind of find out, just cut a piece off a big sheet rather than trying to mark out in the middle of the sheet. I always just cut a chunk off the corner. And what I'm trying to do now is try to decide where there's the least waste, I suppose. So if I go something like that, I'll cut that out roughly, and then I'll show you how I would go about forming it for a more exact shape and size.
While you're cutting there, Nick,
Sorry?
while you're cutting, Steve Hoder has asked, What are the advantages of NS compared to brass?
Well, it's 6 2/3, isn't it? Really, I think nickel silver's a bit stiffer, but it's a bit more difficult to roll. And but then if you roll in a boiler, for instance, out of something that's quite thin, I think it ends up being a bit more rigid if it's made out of if it's made out of nickel silver rather than brass. And I think it's kind of easier to solder. I think it has less of a tendency to sort of distort if you hang around too much with your soldering iron. But I'm just going to cut a corner out of it. And I'll show you the method I use then for getting a perfect rectangle.
Do you have beeswax or talc at all for your blades?
Sorry?
Do you use beeswax or talc for your blades?
No, nothing like that.
So just completely clean.
Should I? Would somebody is that what somebody recommends, that it's a good thing to use, talc or?
Well, I read quite a while ago, many years ago, that for using piercing saws, something like beeswax
Right,
is
okay.
really good. And I've read somebody else somewhere uses talc.
Well, I tell you what, I'll give that a go, Ian. Right, so we've cut a basic kind of shape here, just a piece from which we're going to form our 33.2 times 16 rectangle. That piece was the edge of the sheet, so that's straight. So what we'll do is we'll pop that there on my square, and we'll get my scalpel and just make a nice scar along there, like so.
And you're doing that just as Pete Hutchinson asks, do you use anything to make it easier to see the line that you are cutting?
No, I gave up using
Engineer's glue.
Engineer's blue. I mean, I'd go at using Sharpie as well, but actually the best thing is just to, I think, is just to use the scalpel, really. I've got some dividers as well. I'll just show you those in a second. If you're drawing a curve, like for a splasher, for instance, you can buy these down the I got these from a graphic arts place in the city centre in Sheffield. And as you can see, they're like what would you call those? It's like a cutter, isn't it? It's got a blade in there that's a cutter and a compass point. So you can kind of use that for cutting out or marking out things like splashers, or maybe the balance weights on a wheel, or maybe this part of the boiler, firebox, smoke box, whatever it is you're using. And they're available really cheaply I got this from the graphic arts shop in the city centre in Sheffield here. And it costs buttons, and I think it's even got some blades left inside it as well. So I've scored a line. Now the method I use for getting to that line wouldn't be to cut it with the saw anymore. What I use is a sanding disc, and you can just, because it's 0.3, you can go along the and grind up to the line.
While you're doing that,
And this is obviously much, much, much quicker than using a. And also, if you just orientate the piece that you're grinding, the light shines quite nicely off the score line that you've made with your scalpel, and you grind until you can actually see the line disappear, the shiny line where the score mark was. And as soon as it's disappeared, then you're there, aren't you? So in a few seconds, we should have a piece of nickel silver with a right angle on it. And then, of course, we can quite easily mark the rest of it out. So there you go.
And this probably leads on to Pete's second question. If you end up with an oversized piece that isn't square, how do you go about getting it square?
Well, you just do what I'm doing now. You score a line, and make that straight, cut, you know, cut up to the line so you've got a straight edge, and then you use a square and then score a right angle to that, and now I've got a piece of metal that's square there. Those two sides of it are square to each other, and if you check them in the on me trusty square here, you'll see that they're not quite square.
Mm.
And that needs a little bit taking off there, like that. And now, as I said, yes, there we go. Whether you can see that. But if you hold the square up to the light like that, you can see if there's any light shining through. You can see whether it's square or not. And it needs to be perfectly square for doing this kind of thing. And similarly, a boiler, anything really. So we've got that. That's now square to that. So all you sort of purists need to look away now, because I always cheat and just use my vernier as a scriber. So that's square to that. So if we run this side of the vernier up against that straight edge, then we'll get a parallel line there that's parallel to this. So that dimension needed to be 16. So I've dialed in 16 on my vernier and just scored a line there with the point of that. This is very, very, very bad practice. And ultimately the points on your vernier wear out and you have to buy a new one, but they're not expensive. And then the other dimension that you need is 33.2. So I'm dialing up 33.2. You'll notice mine isn't digital. And scribing there. So now hopefully you can see that we've got a rectangle marked out. Can you see that?
You just bring it a bit closer to the camera, Nick. Just tilt it away. That's it. Yeah.
Have you got it there?
Just about. Yeah.
You can see there's some scar lines that I've made with the tips of the vernier. And if you watch lots and lots of people doing this kind of thing, everybody uses a vernier for marking out instead of a scalpel or a I don't even think I've got a scriber anywhere. I always use the sort of punch off me one of me rivet presses there as a scriber. So we get the old saw out, and we'll cut up to those two lines that we've just scribed. I never use a scraper. James was going on earlier. Would this be the kind of thing that you could do perhaps a bit quicker using a scraper, do you think, James?
I think, yeah, I found the squawker really useful on a longer piece. I'm not sure on a short piece how useful it would be. Don't know, never tried it. I have to give it a go. One thing is worth commenting on, Nick, is the angle at which you're holding that saw and blade. So you're actually holding it quite low. So
Right,
you're increasing the effective thickness of metal that your blade is seeing. And that's important.
Maybe they're good for roughing things out. Do they distort sheet when you use them as a
Don't seem to.
Because that's, I mean, I've tried a few ways of doing this, but this is kind of the most reliable way of not distorting the sheet.
Mm.
You know, because the other thing you need it to be square and you need it to be perfectly flat. And if you've got those two things, then, you know, you can kind of build anything. So again, what we're going to do is we're going to grind along there where I've roughly cut up to the line. And again, what I do, if I orientate the piece of metal, I can see now a shiny line along there where I scored with the scribed with the vernier. And now all I'm doing is just cutting up to it, grinding away up to it.
While you're doing that, Nick, Paul Scott has asked, can we have a look at your sanding disc and where do you get them from?
Say that again, sorry.
Paul Scott asks, can we have a look at your sanding disc?
Yeah.
And where do they come from?
Yeah, I'll show you those. Right. If you go on, I'm sure these are available elsewhere, but if you go on Minicraft's website, they'll sell you this arbor. It's a little shaft that's sort of vulcanized into a a cup here, you know, like a thing that you can stick these pads onto. And you can buy these, but I just started making them myself. Basically, what they are is 180 grit, wet or dry, and buy good quality wet and dry as well, because it lasts longer. And basically, I just draw circles with this and cut them out. Sorry, stick double-sided sticky tape on the back first, and then draw circles, you know, and cut them out. That's really all I do with a pair of scissors, and they just stick on. And when they've worn out, you can stick another one on. And they don't need to be perfectly circular. You'll find that they kind of naturally wear concentric with the shaft of the drill. Anyway, back in a moment when I've done this. And again, I'm going to just go along this edge. And you can see this is a very, very quick way of making quite an accurate rectangle. But I mean, it will need some fine tuning. I find that my vernier, the tips of my vernier are worn a little bit. So you have to go 0.1 under the dimension that you want. But anyway, let's just check it. Now, you know, I know which sides I've done. It's those two sides because they're still rough because I've not finished them off. So if you put that on there, you'll see that that's not quite square. So you need to take a smidge off there, and it is only a smidge. And then measure it again, and that's
Nick,
now a
you
right
seem to have
angle.
got even more quiet.
That's now a right angle, and I'm just going to check the dimension using my vernier, and that is 33.3, and we were shooting 33.2. So experience tells me that if I go, then that'll be 33.2. That's still square. And it's now 33.2. Bang on. And we just needed to check that this dimension was 16, didn't we? And that is 16.1. So we just quickly run down there with that. I think you'll find that's 16 now. Done this so many times. Yep, it is. Cock on. So let's just check that it's perfectly square. Turn it all the way around. Make sure all the sides are square to each other. And they are. I'm quite pleased with that. That's not bad, is it? Quite pleased with the way that's turned out. Right, so we'll get a bit of wet and dry and just finish off the edges. Get any bird material off. And such was my confidence, you see, at not being able to do that. I made one just in case. Then I thought, like a magician, I could swap them over like this, couldn't I? And you wouldn't know which one I'd cut and which one I'd pre-cut. So they're the pieces we need to make this box in here. Now, normally, if you were getting a commercial kit, that'd just come as an etch that you would just an L-shaped etch that you would just fold up. And as I say, I did dig all these pieces out my scrap box that have already got pre-etched lines on to see if I could, you know, scribe out around the pre-etched lines to make that box, but I couldn't. So we'll use those another day. And does anybody want to see how I attach these together so that they're all nice and straight and square?
Yeah, go on.
Yeah, that's what you want to see, isn't it? Now you'll have to bear with me because I've got so many things plugged in here on my workbench that I've only got one plug socket for my grinder and my soldering iron. So let's turn the soldering iron on. Right, so we need to stick these three pieces together. We need to be careful so we get the orientation right, so they sit in this side of the cab, that we make one that's the right hand. So let's start by sticking the top to the side. Just work out how I made that one. Right, so how did I make that? Yeah, you can't see. trying to decide what fits inside which. Oh, I know. Yeah. Right, so you make that, stick that and that together, and then that goes in there. So that needs to be in that orientation, so that that hole there is closest to the edge of the cab. So the inside face will need to go on here. The rear will need to go down here. So let's start with the rear. And what I always do to solder these together is I've got a little aluminium block here that years and years ago someone machined on a mill so that the ends were square. So it's a dead square block. And that is very useful because you can stick with a bit of insulating tape. Line that up using your square there. Line that up like that so that that's the wrong way around. You need to start with the back. What we're going to do is we're going to stick the back on there so that the top is absolutely level. And you see the top edge now of that rectangle is flush with this face. So that's holding that. And then if we put that on that way, like that, so that overlaps, this edge overlaps this face of the rear of that, then that'll hold those two pieces at 90 degrees to each other while we solder. So we'll get another piece of tape. This is just electrical insulation tape, by the way. Right, okay. So what I'm doing is making sure that that edge now is flush with this edge, and this edge is the rear piece that we've stuck onto it. And the rear piece fits underneath the top. But we're following this at home. So stick that over there and just rejiggle it. We can use this to put a piece on the top up against. So we've got now that piece and that piece exactly at 90 degrees to each other, and not quite lined up with each other in this direction. There we go. Just fine tune it with our fingernails. There we go. We'll need some flux. Bit of liquid flux along there. Like so. And then here I've got some 145 solder. Can you see that in the shot? Just on a real look. Just take a tiny, tiny dab of that. Hold the pieces and just solder along there. Like that. And then we can very carefully take this two pieces of tape off. I'll just stick them over there so we can use them again in a minute. Right. So now we've got two pieces, look, that are soldered together at right angles to each other. And I'm not going to clean that, but I'm not going to solder it anymore because no solder's got into the inside face, which will help us in a minute when we stick this back to this block. So that's now a nice right angle, if you can see. So we can put the square on that and you can see that that's quite a nice right angle there. We've got that soldered quite nicely together and the edges coincide, so everything's good there. So Now what we need to do is solder this piece there inside this fold here, inside this angle, like so. So what I'm going to do is stick that with some tape on the edge like that.
And Nick, just be careful you're getting it the right way around.
You're right. Well, yes, you were. Thank you, James. Well spotted. That would be quite embarrassing, wouldn't it, taking it to pieces and soldering it back on. So if I put that up against there, then that is now against this edge and that edge. So we'll put a piece of tape on there just to hold it. That's good. Then if we pop that on there, and that is the right way around. Thank you, James. Just overlap the edge of this piece. I think we'll get away without having to tape that. So what we'll do is we'll tack it here, just here, with a tiny, tiny tack solder that we'll be able to move around. So a little bit of flux, tiny, tiny bit of flux, and tiniest, tiniest dab of solder there. So that's held now, that's all flush. And then we'll move to this bottom corner here, just there, and we'll, if you just press on it with your fingernail, you can line the side of one up to the flat face of the other.
While you're doing that, Nick,
Yeah.
Dr. Davis says, surprised the aluminium does not conduct the heat away.
Oh, it
And
does.
Frank Sharp also says, doesn't the aluminium block take the heat away from the solder?
It does, but really all I'm doing is putting on really small tacks. You know, I'm not putting on a massive, massive, massive solder here. I'm going to take it off the block of aluminium to solder it up finally. I wouldn't be able to do it on this aluminium block.
I suppose the other advantage with it being aluminium as well, it doesn't actually heat soak as much as, say, brass would.
Well, maybe not. There's the biggest advantage is that you're not going to be soldering your nickel silver to it, are you?
No.
So there you go. That's the shape we wanted to achieve. That's all tacked together, and it's all nice and straight and square. So now we can, you know, get in there and solder it up. And if I've tacked it here and here, the best place to start soldering is here in the middle. And I like to solder these on the outside because I'm going to hit them with the rotary sander in a minute anyway. So it'll all, you know, you'll get a nice straight edge. So we've gone along there. Let's join.
So you don't put any solder on the inside at all?
Well, with this, I kind of want to use the solder as a bit of a filler as well, you know, so I can grind it all off. You'll see me doing that in a minute. We just make sure we've soldered all the way around. And
that's still the 145, isn't it?
It's always 145 solder, yeah.
Yeah.
I only ever use that. I only ever use electrical solder for much more structural bits of chassis. Sometimes I do rods, coupling rods and connecting rods with electrical solder because sometimes you want to drill into them. And if you've drilled with a lower temperature solder, then what you often find is that the drill will fracture the layers apart. So that's all. So we've got these two pieces soldered together here, and then this side piece soldered together there. So to tidy that up, all we're going to do is hit it with my rotary sander, which I'm going to have to unplug the soldering iron to do. There we go. So just lightly and carefully going along there, just to take off all the excess solder, just so it's all nice and flat. And then there as well. bit along there where it's flowed over, and I can see there's a little pinhole there as well where I didn't get when I was soldering. So we'll just go back and solder those in there. And just and then finally you can finish it off with a bit of wet and dry just to make it look nice and square and angular. A little bit of solder that's run over the top as well, so we'll just flash along there as well. And you can see the rotary sander is much quicker than getting out a file and trying to do that by hand. And if you charge by the hour, hence thank you for that kind of thing. So there you go, that's the piece that fits in there. And I have to say, that's not a bad fit. Fits in there, it fits up against the frame. We're good. You can see what I did, and I'm going to say I did this on purpose, is this piece is slightly longer than that. And I did that in case I want to shape it into the boiler backhead. I wanted a little bit extra here because sometimes if the backhead protrudes into this splasher area here, you need to have something that you can cut away. But I don't think I'm going to need it in this case. So what I'm going to do is just scar down there and then just razz that piece off. And that should fit quite nicely inside the cab. But of course, what I'll do off camera when you're not watching is, you know, make it fit nice and perfectly. I'm sure you don't want to watch me doing this kind of fine adjustments. It's not very good TV. But this is the kind of thing I do all the time, all day. That's basically all scratch building is.
How much material are you taking off at the moment, Nick?
The what, sorry?
How much material are you taking off?
Oh, well, if it's anything more than if I have to take off anything more than I'd say a millimetre, I'll cut it first with my saw.
All right, okay.
But there you go. You see, that's a really nice angular, you know, perfectly. It's all perfectly at right angles because it's impossible not to get it at right angles because you're doing it round a square block. I mean, it would take you hours, wouldn't it, with tweezers trying to line those up. And that should fit really quite nicely. And it does look into that corner of the cab just there, like that. It fits nicely up against the chassis as well, because you can see that like on the real thing, the chassis there protrudes. Can you see that?
Yeah.
The chassis just protrudes up into the cab. And how the loco's made is that these kind of boxes, the splasher come, sandbox come, toolbox, whatever it is, kind of butts up against the outside face of the chassis. And then I think, although I don't know because it's difficult to tell from the photographs that I've got, I don't think this cab's got a platform. I don't think the cab floor's raised up above the footplate. I think the footplate just has planking across. And that'll finish the floor of the cab then, and that'll all be very nice. So, does anybody want me to demonstrate how I make other shapes?
Circles.
A circle. That's very easy. Circles are very easy.
Okay, what's not easy then?
Well, I'll do a circle. I mean, I'll show you.
I think circles would be good because that's a shape that I think most people would, think about trying to get right and having to get the curve right, and then, like you say, blending into that curve.
Let's demonstrate how you would make one of the things I cut lots of things. One of the things I cut out very often are things like balance weights for the side of a wheel.
Yeah.
So that might be a good thing to demonstrate,
Mm.
And obviously, if you're making a balance weight for this one of these wheels here, I mean, they've already got balance weights, but let's just make another one for fun. The thing to do would obviously, starting point is to work out what the diameter, the outside diameter of the balance weight would need to be. And you can see I've just laid me vernier along a spoke there, because this has got wheels with an even number of spokes. So that's handy, because you can just measure from rim to rim across a spoke, and that's coming out at 34.2. So 34.2 divided by 2
17.1.
17.1.
is 17.1. Take a gold star.
Hey,
17.1. That's what we're shooting for. So you would get that scriber that I showed you earlier. The I think it's called a something cutter, isn't it? I can't remember. And get your trusty rule. Where is it? Somewhere on my bench. There it is. And just pop this on it and set this at 17.1. So, and this again, you just need to do these things really accurately, and they will work. 17.1. That's roughly about right. He said, having just contradicted himself. Well, let's use that connection. I think that's 17.1 of anybody's money. Now, you could just scribe an arc. You could just hit that with a center punch, let's say, and a conveniently heavy tool like these tin snips.
it looks like it's just called a circle cutter, obviously.
Is it? Right, okay. And then obviously then you can you see you just scribe a curve. Like
The other
that.
one would be a compass cutter.
Is it? And then you would go then to, and what I've done is I've just popped it there and, you know, drawn a curve. And then if we were to go to this drawing, we can measure the height, and it is 4.5, but you need to multiply this drawing by 1.03. Can you do that in your head? 4.5 times 1.03. So 4.63, 4.6. So we need to reduce this now by 4.6, don't we? And it was 17.1. 17.1 minus 4.6 is 12.5. So then we need to reset the. And you can see where I'm going with this, can't you? I mean, it is quite tedious. And I've also thrown my rule somewhere. There it is. So we'll go 12 point, what did I say?
$12.5.
12.5. So we'll go 12.5 with this circle cutter. There. Yeah. And then we'll score another. So there we've got, can you see that? We've got two concentric curved lines there that we've
Just
drawn.
tilt it away again, Nick. Yeah, they're just picking the highlights up there, yeah.
Yeah, you see? And then you just cut to those. Simple as that. You would get your saw. And then
Right. While you're cutting again, Michael asks. Sorry?
And obviously the closer you get to the line, the less cutting, the less filing you have to do. You can't do an inside curve like that with a sanding disc.
No.
I mean, you could if you had a drum-shaped one, but I haven't. So I know people have like you can have like a tool that's mounted into your bench, can't you? I think if you look on the Minicraft website, you can see you've got like a rotary sort of a drum sander that's mounted into your bench that you could do that on.
Yeah.
But I don't have one, so I have to resort to more traditional means.
Having done that, Nick, Michael asks, when I cut along a while you've just been doing that, Michael has asked, when I cut along a marked line on brass or nickel silver sheet, sometimes I find that the sawn line veers to either the right or the left.
Right.
How would you account for this? And is it related to the position of one's body in relation to the work and the saw?
Well, you see, I would, if I were kind of doing this for the first time, I know in the olden days I used to cut quite away from the line, so you could kind of correct by, kind of tilting the saw so the blade goes, away or in the direction that you want. But you have to be careful with these piercing saw blades as well, because obviously if you twist the frame, the blade's so thin that the blade's able to rotate in the slot, so you have to overcompensate. But it's like everything else, I think, isn't it? Once you've done it a gazillion times, it's a lot easier, really. And with these, there is really no other way of doing it, I don't think, other than just getting a needle file and just filing up to the line, I'm afraid, and keeps filing and moving along. This one I'm doing with a half round file, as you probably already guessed. And it's all very tedious. And if there is a shortcut for doing this, things like this, I have to confess I don't know what it is. I did look at finding a reciprocating saw once, like a kind of a band saw.
Yeah.
But they don't really work very well. You can get things called a scroll saw, can't you?
Yeah.
But band saws really don't work for material that's this thin, because usually the pitch of the teeth in your saw blade are much bigger than the thickness of your material, so it just tears it.
Yeah.
So I'm afraid it's traditional old method with this. And you just sort of file up to the line. Again, if you orientate the piece so that the light's kind of shining off the scored line, that does help you. And there you can see I've just filed that up to the line. So we'll do the outer one now, I suppose, won't we? What we really need to do, and I can't now because I've cut this piece off here, which was very stupid of me, was to draw a what would you call it? A chord? Is it from the center? From the center of these two curves, I should have drawn a line so that I knew where to cut to get the endpoints of the arc that I'm trying to cut out of this. But we'll come to that in a minute because we'll about mark it out with the spokes, won't we? Now then, saw, there it is. And again, it's just, you can see I'm just holding the workpiece just off the edge of the table that I'm using. And just hold the saw very lightly, because if you don't, you'll end up breaking loads of blades. And you have to hold your piece of metal quite firmly as well, because if it jumps, you more than likely will break one of these piercing saw blades. You'll find yourself getting through dozens and dozens of them. I always buy them by the gross.
Keith Gibson has to go, Nick.
That many of them.
Nick, Keith Gibson says he has to go, but thank you for a very interesting session so far.
Oh, right, okay.
And just before
Thanks very much. Bye-bye. Thanks for coming.
Kelvin asks, how do you fix the balance weight to the outside of the wheel? Araldite. Okay, thank you. He did put super glue question mark, but Araldite. There you go, Kelvin. Other brands are available.
You can adjust. Well, yes, of course. Other epoxy resins are available. You can. with that, it's death or glory with that with super glue, isn't it?
Yeah.
You know, if it's not quite in the right place, you have to peel it off, and then you end up knackering your, well, both things, the thing you've stuck it to and the thing you've stuck to it, you know. But if you
Usually
right,
fingers.
then you get 5 minutes, don't you?
Yeah, and it's usually fingers.
And again, it's just cutting up to the line. Yep. That's scrap now. In my scrap bin. And again, just using the rotary sander just to stand up to the line I scribed. So you can do that with an outside curve. You can use the your rotary, your sanding disc.
Do you have a preferred brand for your piercing saw blades?
Ow, 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 sorry. Say again.
Do you have a preferred brand for your piercing saw blades?
I don't. The only ones I've ever bought, and this isn't a particular endorsement for them, I always used to buy them off Squires. And Squires actually were the ones, they sold them to Eileen's Emporium. So if you got them off Irene's Emporium, which is now defunct, isn't it?
Yeah.
They used to sell the same blades, 6 knots. But I get these now from Hobby Holidays in
Oh, yeah.
and I can't tell what brand they are, look, because the it's on the back there, look, Gladden ones, look.
Fish ones. They're Swiss, aren't they?
I
think.
They're made by Valabi.
Yeah, the Swiss.
Is that a Swiss company?
Yeah, that's why they got the fish on.
Yeah, I'm a bit disappointed they're not from Sheffield, obviously. But the good thing about these blades is that they're a bit more flexible than the other ones. So, you know, you can, if you end up kinking something, if you end up, your blade doesn't always necessarily snap, you know, and the blades seem to, although they cost more each, they're a bit more robust, you know. You'll find yourself like tonight, where I've had one that's cut loads of straight lines and things, and sometimes, you know, you need 3 or 4 to cut something out. It's just, I don't know whether the blades, one's better than others, or it's just you get tired, or you're just unlucky, or whatever. See, I'm going to hold this in my tweezers because it's getting quite hot. What we're doing there is we're just razzing off up to the line, really, with the rotary sander and reorientating it so I can see the line glinting, and I can just sand until it disappears. There we go. So we've got a lump of that now, haven't we? There, look. And now we need to, as I said, I should have, if I knew where the origin was here, I could put a ruler through the origin, couldn't I, and score a line there. But we don't. I forgot to do that. So if we lay that on the wheel, we can use the spoke, then, can't we, as a guideline for squaring the end of it off. So let's razz that off. And then so you lay that back on the wheel, so that's nice and square at that end. So these cover 1, 2, 3, 4 spokes. So 1, 2, 3, 4. So it's that spoke. So we need to be there. Roughly here. So if we just cut outside that line there, then we can adjust it with the sander. This is where I break a blade because it's a very small workpiece now, and it's quite difficult to hold without bending it. Go. that off. See, that's not a bad fit. It needs to go in a bit there. That way. And it's just adjusting. It's just adjusting and offering up and adjusting again and so on and so on. So, and there you see we have it. We've got a nice balance weight there that sits on the edge of the wheel and on the face of these spokes. And if you look closely at these spokes, you can see that they're square section or rectangular section, should I say. So that's kind of how you do a circle. I'm sorry, it's not. There isn't a special tool that allows you to, you know, and it's done. It's just cutting and sawing, I'm afraid. Anybody else got any questions? We're up to an hour. We usually have a Q&A half an hour at the end, don't we?
The drawbar on your loco.
There isn't one.
Well,
This bit.
the plate with the holes in for the drawbar.
Yeah, this bit.
How do you make the holes?
Well, you mark them out and you drill a hole
and
then put your saw blade through it and then just cut around like that.
Okay.
Just make one hole. Well, you know, I would probably have drilled this one here and maybe there as well after I'd scored the shape of the hole that I wanted, and then you know, cut up to it and used, you know,
just use the needle files.
I've got a whole selection of needle files here. I've got kind of triangular ones and square ones.
Yeah.
And you know, rat tail, just round ones and so on, and then you just dress the hole.
Yeah.
It's,
fair enough.
Making a piece like this actually takes forever because it's a rectangle. It's obviously it's a buffer beam or a buffing beam or a drag beam or whatever. And it's got rivets on the end, so you kind of need to mark the positions of the rivets out on the underside of the sheet.
Nick, can you just bring that more central?
Sorry?
You just bring that more central to the camera. You were right, top right. Yeah, that's it. Thank you.
So you can see it's got a line. Can you see it's got lines of? Can you see? It's got lines of rivets there.
Yeah.
There. So you have to mark those out on the. You cut out the rectangle, mark out these 3 smaller rectangles. One's for the, as you say, one's for the drag beam, isn't it? And these are probably for safety chains or something.
Yeah.
And then it's got a line of rivets round there in an upside down U shape. So I would mark those out on the back and then get my favourite rivet tool from over there out and punch the rivet heads out. I would mark each individual rivet as well. I know it's very tedious, but so you know, cut that out, cut the holes, mark the rivets, punch them out, and then you can solder it on. And then you can see there's these 2 little rectangular plates that presumably the buffers and the tender rub against, the rubbing things.
Yeah.
And they're just, again, more rectangles, small rectangles that I've cut out and soldered on.
Yeah.
And the front buffer beam's the same as well. You know, it's got a little pilot hole. It's got a little pilot hole there for the where I'll start opening it out ultimately for the buffers.
Yeah.
And then a little square there for the what do you call it? The draw hook.
Draw hook.
Yeah. But I'll never drill these. The material I think is a bit too thin to drill with a drill that's any bigger than about 2 millimeters. I'll kind of open it out sequentially, going up maybe in 0.5 millimeter sizes. And then I've got a load of taper pin reamers.
Yeah.
Here. Grab one. Quite a big one here. I don't know whether you can see that. It's a reamer that's designed for opening out a hole, a tapered hole, into which you would bash a tapered pin. And obviously, the pin would have to be the same profile as the reamer, and you ream. But these are really good for thin metal because you can open out a hole with them quite nicely. And you know, if you know whereabouts on the reamer the finished diameter needs to be, you can, like I've done here, look, and stick a piece of masking tape around the reamer where I need to stop to give you a hole of a certain diameter in thin metal sheet.
Yeah.
You'll never ever be able to drill a 10mm hole in a 0.3 piece of nickel silver or brass using a drill. It'll just tear the sheet to pieces. So, you know, really you need to use a broach or a reamer, or probably if it's a big hole, a relatively big hole, like 10mm, you probably just need to scribe it with this, you know, and drill a little pilot hole to get your blade through and then put a circle.
Mm.
Would you like me to demonstrate doing that?
Yeah, please.
Okay, let's say we want to put a 12mm hole in this, so we'll make ourselves a pilot hole with a suitably heavy drill.
Now it's interesting you bring those cutters. Are they tin snips?
These?
Yes.
Yeah.
Now then.
I never
Yes.
use them for cutting sheet metal.
Thank you. That's what I was
They
hoping you were going to say.
They just distort too much.
Yeah.
I use them for cutting up pieces of
Scrap.
etch that are useless.
Right.
I actually use them for cutting. You know, if you get a big sheet that's got lots of etches on it, they're quite good for just snipping, you know, round the waste bits to get the bit out you want.
Okay.
I would never use a guillotine or a tin snips because they. I mean, I had a big argument with somebody once at a show about whether a guillotine distorts a piece of metal, and it just does. It sort of curls it up, doesn't it? It turns it into a helix as you pull the thing down. It kind of curls up like that. And, you know, they're just no use.
As regards tin snips, the clue is in the name, isn't it?
Yeah.
They're for tin, not for brass or nickel silver.
Well, maybe.
No.
Tin's more malleable, isn't it? It's more sympathetic to the cut.
I've got this friend who's a absolutely shit hot panel beater, you know, fixes cars and things. Really, really good. Watching him getting bits of sheet metal and making some really complex shapes out of it. But they're not really good enough for this because they're just far too distorted. And he said, well, that doesn't matter if you're making a car body or making a repair or something like that, because ultimately the bodywork people will fill all your imperfections with some sort of filler before, or high build primer or something before they paint the car. But what he does do is he always concentrates on the edges, you know, because when you're making shapes in a flat sheet of metal, you need to make sure that the edges are flat. So he'll kind of beat all the way around the edges and make sure that they're flat, and make sure the thing sits on a big flatbed on his welding table, you know. And you know, it's quite a thing to watch, the way that he can make really quite complex shapes. But it's no use for this kind of thing because you can't really use filler on something like this. So what you're shooting for is, you know, just to finish. You know, the metal needs to be in its kind of finished state when you start soldering it together and sanding it up. Anyway, look, I punched a hole in this piece of what looks like a frame spacer, and I've scribed a 10mm hole in it, a 10mm circle in it. Can you see that?
It's reflecting on your light quite badly, but can't quite see it. Tilt it away from you again.
Yeah, it's hard to tell because it is reflecting the where you think we're looking at is actually a spot.
It's just scribed a 10mm hole. I punched, made a
Yeah.
centre pop there to pop the point of the compass in, and just, well, I mean, the easiest way to do it is to hold that and move the metal, isn't it?
Oh, James, if he'd used engineer's blue, hey.
What I'm going to do,
Shush.
what I'm going to do is bravely get the centre pop and just pop inside that line like that. And then I'm going to get a drill.
Just going back to riveting, you were talking about riveting earlier on.
Yeah.
Does riveting work because you're using 0.3mm material?
It works better. The thinner the material is, the less distortion you get. And obviously the further the rivets are away from each other, the less distortion you get as well. So things like Great Western Railway locos are an utter ball ache to do because there are many rivets close together and you have to get them in a nice straight line, don't you? Otherwise, your eye just goes straight to them and they don't look right. Anyway, so I'm going to drill myself a little hole there, look. Like that. Made a nice hole in my workbench to match the others.
Do you ever, if you're doing a rivet overlay, do you ever use thinner material?
Yes.
Okay.
Yes, I've got down to something like 0.2, although 0.2 is it's easy to form it's good to form the rivets in a nice straight, easy, even line, but it's very difficult to cut out. Even with a 6/0 saw, you know, it's still easy to jink the material while you're sawing.
Yeah.
I mean, you kind of need to saw at an angle, don't you? A kind of a quite acute angle to the surface of the metal, you know, to try not to distort it, and then you lose a little bit of accuracy while you're cutting as well.
Yeah.
But for things like that, to be perfectly honest with you, you're probably better off getting them etched, drawing them in CAD and getting them etched.
Yeah, probably true.
Just going back to rivets, Mark Evans has asked, talking of curling material, which goes back to us, you know, talking about tin snips and guillotines. How do you prevent this when punching a line of rivets? Because obviously, a lot of the time you punch rivets, the material can start to bend, can't it?
It can.
Any technique for preventing that? I know you've mentioned thinner material.
Well, sometimes it helps to have to look at the shape of the anvil. I mean, no, you have a sort of a pointy thing, don't you? And this is my pointy thing here, the punch there in one of the rivet tools I've got, and that goes into a sort of like a anvil, doesn't it? And that pushes your material into that hole to form your rivet. Now, it helps to look at the shape of your anvil as well, because let's say that your anvil is this shape, like that.
Can't really see that, Nick.
Oh, right.
Okay.
How's
That's
that?
a bit, but yeah, that's
so
better.
Let's say this is the punch, and this is the little dimple in your anvil. Can you see that?
No. Turn your light off.
Does that help?
Yeah, that's better.
So if your anvil, that's a little dimple in your anvil into which the punch goes to form the rivet. And if the previous rivet sits here as you're moving the sheet along, and you push down there to form one next to it, and that's still sat on the surface of the anvil, then it'll bend your material. So really what you need to do, and what I did with some of mine, I ended up getting a few off metalsmiths, is make your anvil very small so that the previous rivet never sits on top of the anvil. That really helps.
Yeah.
Does that seem obvious?
That's actually logical, yeah.
Yeah.
That's...
If the previous rivet's still sitting on the anvil, then your material will just curl, won't it, as you're punching rivets out. But there's a limit to this, because if the anvil isn't much bigger than the rivet, then it'll distort, you know.
Yeah.
So there needs to be some sort of structure around the hole, you know, to support the material while you're punching your rivet.
It's almost like you need an anvil that's got slots either side of the anvil itself, isn't it? So you've got material that can hold the metal.
Well, that's
and you
right.
can slide it along.
The anvil I've got, what I've done is I've ground pieces off the edge of it. So it's actually, if you look on it from the top, it's kind of like that shape, curved, and the whole thing is there. And then when you're punching, and this distance is different from that distance. So at least you've got some means of registering how far apart the rivets. If you go that way, the rivets will be close together. If you push the material that way and then slide it back so the rivet hits the rivet you've just punched hits against the flat there, then you've got a set spacing, haven't you, of each rivet. And what my rivet tool's got is like a cam that you can put over this. It's a circular former that's kind of offset, and if you turn this round, you can alter the rivet spacing effectively using that.
Yeah.
But it's not very, you know. And then you get those Tony Reynolds ones, don't you? That I think Lee Marsh sells them now, doesn't he? And they've actually got a you know, an XY table on them, so you can move the workpiece along, you know, by whatever point
Point
8
one, probably, isn't it?
You know, and you know, it can get quite sophisticated. And once you get to that stage, actually, it's easier just to go to your friend who can do CAD and just ask him if he'll draw it for you, you know, with some half-etched rivets in it, because that's kind of the best, I think, the best way of doing that. Anyway, back to this hole. Where's me? Oh yeah, right. I as you can see, look, I drilled a hole, and can you see what I've done? I've shoved my saw through the hole, and then you just, again, you holding the workpiece there firmly on the edge, just over the edge of the table, and just, you know, moving your saw up and down very gently, turning the workpiece very slowly, cutting as close to the line as you brave enough. Then you just keep going round. I don't think you would ever cut a 10mm hole in a piece like this. And again, I'm holding this piece. I'm rotating this in a way that light's shining on the line I've scribed, so I can see it quite clearly. And I can cut right up to it. And it's just experience, really. Practice and experience. We go back at the hole. Bing. There you go. Look, there's a hole in the
Excellent.
sheet metal that just needs a little bit of dressing up. Take that out, we saw. Retension the blade. And then I think if we can get a round file that's the right diameter, where's this? Yeah, that's less than the diameter of the hole. So we can just file up to the line. And 2 minutes later, you'll have a perfect 10mm hole in there. That's the way I would do it. Yeah. And I've also got things like this. But I suppose the other thing that nobody's asked is folding material. I mean, I watched somebody using a hold and fold. You know, sometimes when you want to fold along a half-etched line with something like this where there's lots of material, it's quite easy, isn't it, to just excuse me, just sort of fold it by hand, you know, a little bit, keep going along, you know, you're never going to fold it in a one. So
Bless you.
if you just go along and just fold it bit by bit like that, just a little bit at a time, and then get something that's square. A little bit of aluminium will do it. Where was it? Somewhere on my workbench. Anyway, just pop your square in there, you know, and just keep bending until it's square all the way along. Sometimes if one side's not very tall and you can't really get a grip on it, who is it that sells those hold and fold things? They're quite useful. Or you can, you know, you can just get a piece of this is just a piece of scrap brass etch that I folded over on itself there. So you can use it as like a kind of a folding bar, can't you? And slip the thing you want to fold inside it like so. And then clamp it up in your vise, which is over here just off shot. And then you can bend it over with your thumb. But sometimes, you know, if you can actually cheat. I'll show you how to do that, because that's quite a useful thing as well. To make your own fold lines, it is actually possible to do that. So let's say I wanted to make a fold line across this. So you get yourself a piece of scrap brass or nickel silver, and just kind of scribe a line where you want the fold to be, like that, with your scalpel. And if you want the fold to be there, then you need the center of the groove that you're going to now carve into it to be right in the middle of that line. So you need to measure the thickness of your grinder, which in my case is 0.5, 0.6. So I need to draw a line 0.3 millimeters away from that. Now, obviously, I would have done this with a vernier, and it would have been easy to have drawn a line 0.3 down from that. But let's just say that's it there. And then if you get that and solder it, excuse me, I'm just going to have to, I'm sharing plug sockets here with various devices. So if you then get a piece of scrap etch with a straight edge, it has to have a straight edge up against the line below the one where you want the fold to be, like that. And then if you just solder it on, solder these two pieces together, like that. Then you can put one of these slitting discs into your drill. So I think these are slitting discs that you can get just about anywhere, can't you? I know Phil Atkinson at Hobby Holidays sells them, and Slater's sell them. And you get these arbors as well with them. And then obviously you can put the grinding wheel then up against the piece of scrap that you've soldered on and just go along with the grinder up against the piece of scrap. And don't go too deep, take a bit out at a time. And when you've done that, you can break this off with your soldering iron once you plugged it back in. Oh, your soldering iron's gone wrong. There we go. We just unsolder this. Get all this excess solder off. Flick it off with your thumb if you're quick.
Gonna say, have you got asbestos fingers?
Well, I used to work in catering, so I got them.
Oh, of course, yeah.
And then you can, you know, what I'm doing now is just getting all the excess solder off. Yeah, you know, nicely finish your bit of material. And there you've got a folding line, haven't you, that you can use to fold your material, like so. So, or not in this case, because I did it too close to those two half etched holes for the tabs. But yeah, that's how you can make your own sort of half etched slots for folding material if you want to do that as well.
Brilliant. Thanks, Nick.
It's 9:30. Is that your lot? Has anybody got any other questions?
No, that looks pretty good at the moment. Let's just wait a moment, see if anybody has got any
Does
questions.
anybody have a last question before I toddle off to my gin and tonic?
No, it doesn't seem so.
Anybody got anything else you want me to demonstrate before we?
Well, I was going to say, if anybody would like to unmute to ask a question of Nick, please feel free to do so. It's like all satisfied, Nick. You've astounded them with your mastery of the piercing saw blade.
It's just practice, guys. It's just practice.
No, yeah, thank you very much, Nick. I think yeah, I've learned a few things today. It's amazing. I mean, it doesn't almost doesn't matter how much you think you know. There's still something that you can learn.
Well, that's right. Every day's a learning. Every day's our school day, isn't it?
Yeah, yeah, very good.
I'm the same. You know, it's always useful for me to have these. I didn't know that you could use a scroker until an hour and a half ago.
Some comments that have come in. Alex says, no questions. Cheers for the session tonight, Nick.
Welcome.
Pete Hutchinson, no more questions, Nick, but I have picked up some very useful tips. Many thanks. Enjoy your G&T.
I will.
Mark Evans, thanks, Nick, and all. Very informative. Maybe see you on Saturday.
Yeah, hello, Mark. Yes, and see you on Saturday.
Dr. Dave, many thanks, Nick. Stephen Spells, many thanks, Nick. Some useful advice. Steve Bannister, thanks, Nick. Very interesting and helpful. Ian McCormack, many thanks, ditto. Frederick Kleckner, thank you for some. Oh, Alan Kleckner, I do apologise. Thank you for some great tips. Michael, Galaxy Tab A. Thanks, Nick. I've learned so much tonight, Michael.
Jolly good.
Cheers, buddy.
Glad I could be of some use. See you all soon. I'll see you all at Kettering. I'll be on. I'm not going in a guild capacity. I'm going as a trader on Saturday. I'll be with Warren Haywood. So I've got a few things that I need to drop off and pick up.
Paul Scott also says, very interesting, Nick. Thank you. And I'll hand over to Mr. Aitken now, who can do the wrap up.
Well, thank you very much, everybody, for attending today. That's been a very interesting session. I've certainly found it useful. And thank you again, Nick, for a very informative talk. And Ian for helping me host the session. So,
pleasure.
Good night, everybody. And
no, PowerPoint.
Oh, yep, sorry. Yes. Right. Wait a minute. I'm just gonna. Let's get remove spotlight. Right, there we go. So I need to screen share. Right, this is our next session on the 26th of March, an evening with Will Heath, talking about making buildings with card materials. So I hope you'll all be able to join us for that session. That certainly sounds interesting as well.